Is time travel possible? Today we're going to explore some science that could blow your mind. And by the way, I don't mean just one theory, but 7 of them. And if you like the sound of that, please hit subscribe because we are going to go on an incredible journey through space and time. Ready? Let's do it. Number 7, time dilation. Now this is Einstein's special relativity. It is the most widely accepted theory in physics today. As far as time travel goes, this is only the tip of the iceberg. You may have heard that time is relative. It depends on your frame of reference. This means if you were to take 2 clocks, put them next to each other, they will both keep the same time, but if one of them were to start moving, say at high speed, then the clock that was moving would be observed to tick slower from the perspective of the clock that was stationary. The faster the moving clock traveled relative to the other, the slower it would appear to tick. And this happens because the speed of light is constant. It never changes regardless of how fast you yourself are moving. So if you move at high speed, say 90% the speed of light, then time slows down for you relative to someone who is not moving at that speed. This is called time dilation. In principle, if you were to travel at the speed of light, time would stop completely for you. Now this may sound weird, but there is actually evidence for it. From satellites used for GPS, these satellites are in orbit around the Earth and they do experience time dilation. If you want to understand more about this, I recommend checking out some videos about GPS and relativity. But the upshot is that these satellites have to account for time dilation when calculating their position. Otherwise, the GPS system would not work. Another example is with astronauts who travel very fast in the upper atmosphere and orbit around the Earth. They experience time dilation, which means when they come back to Earth, they might be younger than their identical twins who stayed on Earth. Now, it's not a lot, but it is measurable. And I have a video about the twin paradox if you want to learn more. All this is to say that time dilation has been proven. There is no doubt about it. And it is the basis for what is known as closed time-like curves. A closed time-like curve is a path through space-time that starts and ends at the same point. If you were to travel on such a path, you would end up traveling back in time. However, this only works if you have negative mass. And as far as we know, negative mass does not exist. But let's just assume for a moment that it did. Then it would be theoretically possible to travel back in time using closed time-like curves based on time dilation. However, we can say with certainty that this does not happen because if it did, we would have evidence for it. No, 6 wormholes. Wormholes are also based on Einstein's theory of general relativity, except this time it's general relativity plus the idea that space can have a negative curvature. We can talk about this another time, but just know that this is different from time dilation. Wormholes are sometimes referred to as Einstein-Rosen bridges, and in theory, they connect 2 points in space-time. What makes them interesting for time travel is that the 2 points might be very far apart in time, meaning if you were to travel through one, you would travel into the past or future. Now, it's important to distinguish between traversable wormholes and non-traversable ones. Non-traversable wormholes are those where the mouth of the wormhole leads to an inevitable crushing singularity, whereas traversable wormholes lead to a region of space-time that you can actually pass through without being crushed. The issue with traversable wormholes is that they require exotic matter to hold them open. Again, exotic matter is hypothetical. It doesn't exist as far as we know. And because of this, the mathematics of wormholes is largely speculation. There is no evidence that they exist, and so whether or not they could be used for time travel is unknown. Number 5, black holes. If you want to see extreme time dilation in action, then look no further than a black hole. Because of the intense gravity near a black hole, time slows down dramatically. Remember that time dilation caused by velocity gets extreme as you approach the speed of light, and the closer you get to a black hole, the faster you will need to move just to stay in orbit around it. Therefore, time dilation caused by gravity gets extreme the closer you get to a black hole. If you were to cross the event horizon of a black hole, time would effectively stop for you relative to an outside observer. For someone far away from the black hole, however, time would continue to pass normally. If you were to fall into a black hole, any light that escaped from the black hole after crossing the event horizon would appear to be blue shifted, meaning that the light would be blue shifted. And since nothing can escape from a black hole, it means that no light can reach you from the future. So you would never know that you had fallen into a black hole. But if you were to somehow survive falling into a black hole, then once you cross the event horizon, you would be able to travel back in time. Remember that in order to travel back in time, you only need to get close enough to a black hole that the time dilation effect causes you to be younger than someone else who did not experience that time dilation. How close you need to get to a black hole to achieve this is currently unknown because, as far as we know, no one has ever fallen into a black hole, but it is theoretically possible. One problem is that no one could actually survive falling into a black hole, so it wouldn't really help us with time travel all that much. Now for typular cylinders. A typular cylinder is a hypothetical infinitely long rotating cylinder that has a ring of matter at each end. It is interesting for time travel because it allows for closed time-like curves to exist. However, typular cylinders are only possible if the matter in the cylinder rotates at superluminal speeds. This would require exotic matter. So again, they are hypothetical. That said, there is a similar object known as a cosmic string that could potentially allow for time travel. However, these are also hypothetical and do not exist as far as we know. The reason why I included them here is that they are visually interesting and make for a nice break in the video. Number 3, grandfather paradox. The grandfather paradox is a thought experiment in which someone travels back in time and kills their grandfather before their parent is conceived. This creates a paradox because if the grandfather dies before the parent is conceived, then the parent cannot be born and therefore the time traveler could not exist. This paradox highlights a major issue with time travel, which is that if it were possible, then the timeline would need to be fixed, meaning you couldn't change the past. This is because every event in the past led to the next event and so on until the present day. So if you were to change something in the past, then it would create a contradiction. For example, if you were to kill your grandfather, you would not exist. Therefore, you could not have traveled back in time to kill your grandfather in the first place. This is known as the Novikov self-consistency principle. It basically says that the past is unchangeable. If something happened in the past, then it happened for a reason and you cannot change that reason. No, 2, many worlds interpretation. This is also known as the parallel universe's interpretation of quantum mechanics. In this interpretation, every time a quantum event occurs, the universe splits into multiple universes, each representing a different outcome. This means that every possible outcome actually occurs in some universe. Now, this is speculative. It is not a scientific theory in the same way that general relativity and quantum mechanics are theories. However, it is a very popular interpretation of quantum mechanics and it has a lot of supporters. The reason why I mention many worlds here is because in this interpretation, time travel is possible. If you were to travel back in time, you would be traveling to a parallel universe in which things are different than in your own universe. In this way, you could change the past in one universe without contradicting the past in your own universe. However, this is highly speculative. There is no evidence for many worlds and whether or not it's true is currently unknown. No. 1. Novikov self-consistency principle. This principle says that the past is unchangeable. It is based on the idea that every event in the past led to the next event and so on until the present day. So if you were to change something in the past, then it would create a contradiction. We already talked about the grandfather paradox earlier. This is an example of the Novikov self-consistency principle in action. If you killed your grandfather before your parent was born, then you could not have existed to kill him in the first place. But there is another aspect to the Novikov self-consistency principle. It is the idea that the past is already set, meaning that even if you could travel back in time, you could not change anything. Everything that happened in the past happened for a reason. And finally, we have the bonus item, which is quantum retrocausality. This is the idea that the future can influence the past. It sounds crazy, but it's actually a thing that happens in quantum mechanics. It's called an example of a backward time causation. I have a video about this, but it is a bit technical. So if you're interested, check it out. And there you have it, 7 ways that time travel might be possible. What do you think? Is time travel possible? Let me know in the comments below. And if you enjoyed this video, please hit subscribe. Thanks for watching. See you next time.